Well, if we want to prove they're all congruent, there's going to have to be an angle 2 in here.
Yeah, and where else?
And in this triangle.
Yeah, where's angle 2 in that triangle?
It's this angle.
It's this angle here.
So, well, how can we show that this is also angle 2?
Okay, well, let's see if we can get there. There's something pretty natural you would want to call angle 3 at this point.
Well, just to round it out, because we have a straight line,
Yeah.
this could be angle 3, so we have 180.
This could be angle 3.
So, this has to be angle 3.
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 Which forces this to be angle 1.
Which forces that to be angle 1.
So this has to be angle 3.
This has to be angle 3. Good.
So we have another straight line. I think this has to be angle 3. Because we have the parallel lines again.
For the parallel lines, this has to be angle 3. Okay.
Which forces that to be angle 1.
Which forces this to be angle 1. I'm sorry. Angle 1.
And then that means this is angle 2.
That's angle 2. And you're just missing one angle 3.
And this is angle 3.
This is angle 3 for 2 reasons. It's opposite that angle, and it's also inside this triangle.
And it's on a straight line with those.
It's on a straight line with this, actually, so for 3 reasons. So all of a sudden, I got 4 congruent triangles in here. If I call this, I'll make the tick marks on the side corresponding to the tick marks on the angles that they're opposite. Okay. All these triangles are congruent by side, angle, side. Angle, side, angle. Angle, side, angle. So this means this is 1, this is 2, this is 1, this is 3, that side.
Yeah.
This is 3 here, and this is 2. Got it?
Yeah.
So what is amazing about the big triangle now?
Well, the big triangle is similar to the small triangle.
The big triangle is similar to the small triangle, and what? What else?
Well, all 4 of the little triangles are congruent, we already said.
Yep. What's interesting about the big triangle?
Well, the sides are double.
Okay. The sides here are called the big triangle X, Y, Z. The sides are double the sides of the smaller triangle, which means these points here turn out to be the midpoints of the side. And because of your very first observation from the parallel ideas, I got a bunch of right angles. Means these are the perpendicular bisectors of those sides. Sorry, which means the altitudes of the small triangle
They're the perpendicular bisectors of the big
are
triangle.
the perpendicular bisectors of the big
And we
triangle.
already know perpendicular bisectors meet at a point.
We already know perpendicular bisectors meet at a point. Why do we know perpendicular bisectors meet at a point?
Well, because this point's equally distant from all 3
Right.
vertices.
Because that's the point that's equally distant from all 3 vertices. It's the center of the circumscribed circle. So we just proved that the altitudes. Sorry. Oh boy, I made a mistake. I pointed to the wrong triangle. The altitudes intersect at a single point. That point is the center of the circumscribed circle of this bigger triangle, not of the smaller triangle. Because the altitudes of the small triangle here are the perpendicular bisectors of the bigger triangle. So the point where the altitudes intersect is the center of the circumscribed circle of this larger triangle that we drew. Okay?
Yep.
That's a cool proof. Little harder. Sorry, I'm a little sick and we may not have explained this super well, but this is all geometry. There's not a single number on the board.
Except for 70.
Okay, except for 70. All right, very good, sweetie. Very good.